Welcome back to the Chaos Theory with your host Rahul. Today marks the 34th episode of our 50-day journey exploring chaos in various disciplines. Yesterday, we delved into the intricate dance of chaos in nature, witnessing its breathtaking manifestations across ecosystems. But today, we embark on a captivating exploration into the realm of neuroscience, where chaos intertwines with very fabric of our minds. Join us as we unravel the enigmatic dynamics of the brain, a labyrinth of billions of neurons firing in chaotic harmony. Through the lens of chaos theory, we'll unveil the intricate patterns and emergent behaviors that define our cognitive landscape, from nonlinear dynamics to critical and self organization. We'll journey deep into the neural networks that shape our thoughts, perceptions, and actions. Get ready to expand your understanding of chaos as we uncover its profound connections to the mysteries of human brain. Welcome to another day of enlightenment on the chaos theory. Alright, let's break it down. Have you ever heard of chaos theory? I mean, of course you have heard of chaos theory because I've been rambling about chaos theory for the last 35 days. It's this fascinating concept that dives deep into the study of nonlinear systems. Now, what does that mean? Well, it's all about systems where tiny changes in the beginning can snowball into huge differences down the line. I think this line would have been encapsulated by your brain because I've told this exact line a multiple of times now. So moving on, think about the brain. It's the epitome of nonlinearity. It's this complex network of billions of neurons firing off signals, influenced by all sorts of factors like feedback loops, connections between neurons called synapses, and everything happening in the world around us. Now, why does this matter? Understanding this nonlinear dance with our brain is key to unlocking how our minds work. Imagine your brain as the intricate orchestra. Each neuron is like a musician playing its part. But here's the thing, one tiny change in how a musician plays can ripple through the entire orchestra, changing the whole piece of music. That's the essence of nonlinearity in the brain. It's this delicate balance of chaos and order that shapes everything from our thought and memories to how we perceive the world around us. So, when we talk about deciphering the brain functions, we are talking about unraveling this beautiful symphony of chaos and complexity within our minds. Alright, let's dive into the idea of complexity and emergence in the brain. Picture this, the brain is like a bustling city, with countless interactions happening all at once. At its core are neurons, the building blocks of our thoughts and actions, and synapses, the connection between them. Now, here where it gets interesting. The brain's complexity doesn't just come from each neuron doing its own thing. It's about these neurons interacting with each other. It's like symphony of activity, where each neuron playing its part in this grand orchestra of the mind. But here's the kicker. You cannot understand the brain's complexity by just looking at individual neurons. It's the interaction between them that give rise to emergent phenomena, things that pop out of the interactions that you couldn't predict by studying each part alone. Chaos theory helps us make sense of this. It shows us how these complex patterns of neural activity emerge from collective behavior of neurons. It's like watching a flock of birds or a school of fish. They move together in a synchronized dance, creating something bigger than the sum of their parts. So, when we talk about self-organization and synchronization in the brain, we are talking about how chaos theory helps us understand this mesmerizing complexity of our minds, the intricate web of connection that makes us who we are. Let's talk about dynamical systems. Imagine you're tracking the path of a leaf caught in a swirling breeze. The leaf's journey through the air can be seen as a dynamic system, a system that changes over time. Now, dynamical systems gives us the tools to understand how these systems evolve. In neuroscience, it's like looking at the dance of neural activity in our brains. We can think of each state of the brain's activity as a point in a high-dimensional space, and dynamical systems helps us map out this trajectory through the space. Along these trajectories, we encounter attractors, like points of stability and bifurcations, where the system branches off into new behavior. So, when we apply dynamic system theory to the brain, we gain insights into the patterns and behaviors that characterize neuroactivity. It's like unraveling the intricate choreography of our thoughts and actions, revealing the underlying dynamics that shape our minds. Alright, let's talk about criticality and self organization in the brain. Picture a tightrope walker balancing on a thin line between order and chaos. That's where the brain operates, near what we call a critical point. At this critical juncture, neural networks achieve a delicate balance where they are neither too rigid nor too chaotic. Now, why is this important? Well, it turns out that when the brain is in the critical state, it's like firing on all the cylinders. It exhibits optimal information processing capabilities, allowing it to adapt quickly to whatever the environment throws its way. Chaos theory helps us understand how the brain self-organizes into these critical states. It's like uncovering the secret recipe for how our minds find the perfect balance between stability and flexibility. So when we talk about criticality and self-organization, we are diving into the remarkable ability of the brain to navigate the ever-changing world around us with a glance and efficiency. Let's delve into the functional implications of neurochaos. How understanding the chaotic dance within our brains can shed light to crucial aspects of cognition and behavior. Think about decision making, memory formation, and even consciousness itself. These are all fundamental processes of the mind, and chaos theory offers a unique perspective on how they unfold. Take decision making for instance. It's not just about weighing pros and cons, it involves a complex interplay of neural activity, where chaotic dynamics may influence the outcome. Similarly, when we form memories, it's not a straightforward process. It's shaped by the chaotic patterns of neural connections, being forged and strengthened. And what about consciousness? It's one of the biggest mysteries of neuroscience. Take chaos theory, for example, where it suggests the emergent properties of chaotic neural activity may hold the key to understanding the consciousness arises from the physical process of the brain. By studying these chaotic dynamics, researchers can uncover the underlying mechanisms of these cognitive processes, offering insights that could revolutionize the fields ranging from psychology to artificial intelligence. So, when we talk about neurochaos, it's not just exploring the complexity of the brain, we're unlocking the secrets of the mind itself. Now, let's discuss the clinical relevance of chaos theory in understanding and treating the neurological and psychological disorders. Conditions like epilepsy, Parkinson's disease, and schizophrenia may involve dysregulation of brain dynamics, essentially the chaotic dance when the brain goes awry. Chaos theory steps in a framework to decipher these aberrant dynamics by studying how chaos manifests different in different disorders. Researchers gain insight into the underlying mechanisms. This deeper understanding opens door to new diagnostic tools and therapeutic approaches. Imagine being able to pinpoint the specific patterns of chaos associated with each disorder. This could revolutionize how we diagnose and treat them, leading to more personalized and effective interventions, from innovative brain stimulation techniques to tailored medication regimens. The application of chaos theory in clinical settings hold immense promise for improvising the lives of those affected by these conditions. In conclusion, the exploration of chaos theory's insight into neuroscience reveals the intricate and dynamic nature of the brain, from nonlinear dynamics to criticality and self-organization. Chaos theory provides a powerful framework for understanding how neural networks operate and how they give rise to complex cognitive processes. Moreover, chaos theory's application extends beyond basic research, offering promising avenues for diagnosing and treating neurological and psychiatric diseases. As we wrap up today's episode, it's clear that chaos theory not only enriches our understanding of the brain, but also holds significant implications for clinical practices and beyond. Join us tomorrow as we venture into the realm of philosophy of mind, exploring chaos theory's implication for consciousness. Don't miss out on another captivating discussion on the chaos theory. Thank you for tuning in, and until next time, keep embracing the chaos. This is Rahul from Chaos Theory, signing off.